everyone. I think my voice is clear and my screen is visible to you all. So, in the previous class, uh, we are waiting at least for 2 or 3 minutes more for the students to join. So, till then, in the previous class, what we have studied about rigid body. What is a rigid body? What is rotational motion? What is translational motion? That's all we have studied in the previous class. So, in today's class, we are going to discuss about moment of inertia. Okay, so we are starting the class. Hello, Yasmita. How are you? So, moving further. So, first of all, in today's class, we will discuss about moment of inertia. This is a different term that I think someone of you might not heard about. So, if I say in the translational motion, you have heard the word inertia. Mass behaves as a inertia actually. Mass behaves as the inertia. So, when we say that a body is rotating, then the position offered to its rotation is known as moment of inertia. Are you getting my point? Then the opposition offered to its rotation is known as moment of inertia. So what if I say a body has moment of inertia 2 and another body has moment of inertia 5? So which body has more opposition to the rotation? Then your answer will be the body which has moment of inertia 5 is having more position to the rotation. So what is defined here about moment of inertia? The inertia offered by a body to its rotation is called moment of inertia. This is very simple term. It is also known as rotational inertia. Also known as rotational inertia. Okay. So now, how do we calculate this moment of inertia? On which factor it depends? So we will discuss these things actually. Okay. Now we are going to describe the moment of inertia in more details here in this slide. We are describing moment of inertia of a system of particles. Now let's consider a system of particles like that. This is our x and y axis, and these are the various particles. You can name them one particle, second particle, third, nth particle. So these are the particles. One more thing that was discussed in the previous class, that when a body rotates, the most important thing is the axis. The axis is the line about which body is rotating. For example, if you open and close your door, can you see that door is also, if there, have you seen the door at the park, gate of the park actually somewhere, that round shaped gate, that one person enters, it rotates and it rotates, completely rotates. Can you find the axis of rotation of that gate? That is from the center of the gate, na? That is from the center of the gate. So most important thing in rotation is the axis. So when I talk about moment of inertia or the rotational inertia, the important thing is the axis. So let's consider the axis is our z axis. These particles are rotating about z axis. So how moment of inertia is defined as, it is denoted by I, and it is defined as summation mi ri square. Here, mi is the mass of the ith particle or any one particle. You can say ri is the perpendicular distance of that particle. I will mention these things here. So it is from I equals to 1 to I equals to n. Now, this is just formula thing. What I'm telling you, just listen to that. These are particles, let's suppose first particle, second particle, third kind of particles. So how you will write moment of inertia of these particles or these group of particles as mass of first particle into perpendicular distance squared. R1 is what? Perpendicular distance. From where? From the axis. For the second particle, you will write M2 R2 square. And for the third particle, you will write M3 R3 square and so on. This is how you write moment of inertia. Is it clear? So what is the main thing here is that what is R1 or what is, you can say, what is R? R is the perpendicular distance of the particle from the axis of rotation. So is the formula clear to you? If you have two masses, then you will write m1 r1 square, m2 r2 square, and you need to remember the r is the perpendicular distance from the axis. And for that, you must know the axis. So we will take some examples so that the things will clear in your mind. Okay, moving further. So there is a concept test for you. And I hope that you have seen the previous lecture. You got 2 days actually in between. So the question says find moment of inertia about an axis passing through A, B, and center of mass along the y-axis. Now, first thing you need to understand the question. They are saying that there are three axes. One axis is passing through point A. One axis is passing through point A. Another axis is passing through point B. And the third axis is passing through center of mass of these two masses. And you need to you need to find the moment of inertia about these three axes. That means there will be three answers. There will be three answers. Why three answers? Because moment of inertia about each axis will be different. So let's start. The first axis, they say that passing through point A along the y-axis. So we will draw the axis here. Passing through A along the y-axis, can you say that this is going to be our axis? The situation is, can you imagine that this is the system that is given. This is point A. Okay. This is point A. This is point B. This is mass B. And it is folded like that. The axis is passing through point A and then it is being rotated. Then it is being rotated. This is the situation. If I hold it from B and the axis is passing through B, then the situation will look like that and it is rotating like that. So we need to calculate the moment of inertia in all these situations. Okay. So first about A. So we will see about A. What is the formula for moment of inertia? That is I is equals to how many particles or masses are there? You will say two masses are there. So we will write m1 r1 square plus m2 r2 R2 is 2. So I will become one mass is 1 kg, or you can say mass is 1 kg into perpendicular distance of this mass from the axis. Can you see that this mass is lying on the axis? This mass is lying on the axis. So its perpendicular distance will be 0, plus second mass is of 2 kg, and its perpendicular distance from this is this blue line or this axis is, can you see that this distance is 3 meter? So square of 3. So it will become 18. It will become 18. Can you find the unit of this moment of inertia? Can anyone find the unit of moment of inertia? Anyone? It's quite simple. Moment of inertia is what? Moment of inertia is mass into radius is mass into distance square. That is kg into meter square. Kg into meter square. So you can write the unit as well, kg meter square. This is about A. Now we will calculate about B. About B. Again, we will do the same thing. We will draw the axis, and the body is rotating, or the system is rotating about this axis. Now again, moment of inertia is m1 r1 square plus m2 r2 square. m1 r1 square plus m2 r2 square. Mass is 1 kg, 1 kg, and its perpendicular distance from the axis. This is the axis, and this distance is 3 meter. Squared up is 9, plus mass, another mass is 2 kg. Can you see that 2 kg mass is lying on this axis? Let this is axis 1, this is axis 2. It is lying on the axis. So this distance is 0. So moment of inertia is 9 kg meter square. Now, the third question is very interesting. It involves the concept of center of mass as well. So now, first of all, what is the question say? It's saying that find the moment of inertia about the center of mass. So first of all, you need to locate the center of mass of the system. You need to locate the center of mass of the system. And I think everyone knows the center of mass, how to locate the center of mass of the system. So let's suppose the center of mass is at a point C. Center of mass is at a point C. So its distance from the center of mass, let's suppose from A, this distance is x. So x is given as, we have studied now, center of mass. So how it will be calculated as, I think you remember m1 x1 plus m2 x2 divided by m1 plus x2. Or what we have calculated for two mass system is m2d. About A we are calculating. So m2 will be 2 kg into separation is 3 meter divided by total mass is 1 plus 2, that is 3. So x will be 2 meter. So what we have calculated that this distance is 2 meter. Then this distance will automatically be 1 meter. So now we are going to calculate about center of mass. How it will be calculated? You will again write I is equals to m1 r1 square plus m2 r2 square. Mass is 1 kg, 1 kg, and the perpendicular distance from the axis of 1 kg. This distance is what? 2 meter. So square will be 4 plus Second mass is 2 kg and its perpendicular distance is what? 1 meter. So it will be 4 plus 2, that is 6 kg meter square. So we have got three answers here: 1, 2, and 3. These are the three answers. You can ask me if there is any doubt. Okay. So I think the question is clear to you. So we will move further. Now, there is another question. Have a look at the question. Three particles, each of mass m, are situated. Each of mass m are situated at the vertices of an equilateral triangle of side L. Find the moment of inertia of the system about the line perpendicular to AB in the plane of ABC. Why I have written so much of language in the question? Because after reading the question, the first thing that you need to identify is the axis. So first of all, just focus on the axis they are talking about. They are talking about the line perpendicular to AB in the plane of ABC. So this is the line AB. This is the line AB, and perpendicular to AB will be in two cases, like in y direction or in z direction. Suppose this is our x-axis, this is our y-axis, and this is our z-axis. X, y, and z-axis. So AB is along the x-axis. So perpendicular to it will be either in y or in z. But the question says in the plane of ABC. In the plane of ABC, so that means our axis is this one. So this is our axis. So first of all, we have identified the axis. This is perpendicular to AB and in the plane of ABC. Now, what we will do, there are three particles, each of mass m, 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 and m. So we will write moment of inertia I is equals to m1 r1 square plus m2 r2 square plus m3 r3 square. All those students who are coming late, it's actually not good for you. It will hamper the questions, actually. It will disturb you, in fact. So you are coming late, so it will, JNV Akola, you are coming late now, so it will disturb the questions and scenarios that you are facing. So now I is equals to m1 r1 square. So after this, I am saying, let's suppose I is equals to, this is our first mass. We don't actually, I need to identify m1, m2, m3. Just pick one mass and multiply it by the perpendicular distance of that mass from the axis. So first mass I have taken as m. This one as first mass I am taking. I am writing it for your sake. Into perpendicular distance of this mass from the axis. Can you see that this mass is on the axis itself? So its perpendicular distance will be 0. Plus second mass I am taking this one, that is m, into perpendicular distance. The perpendicular distance side of the triangle is L. So this distance is the perpendicular distance from the axis. This is L square. Plus third mass, I am taking this as a third mass, m, into the perpendicular distance of this mass from the axis. Can you see that? That perpendicular distance of the mass, this is the perpendicular distance. So this is going to be our R3. So what we need to do, we need to calculate this distance. Can you see that? This is this is equilateral triangle. So this angle is 60. Then this will be 30. This will be 30. And we need to identify, we need to calculate R3. So R3 will be, I am writing it here, in right angle triangle, this right angle triangle, R3 is the perpendicular. Perpendicular is what? Hypotenuse into sine theta. That is L by geometry. You can also calculate that. I am just telling you a way actually to calculate these things. So R3 is what? L by 2. So square, if you square it, it will become L square by 4. So moment of inertia will become ml square plus ml square by 4. It will become 5 ml square by 4. This is your answer. I think these two questions will clear a lot of things in your mind. So now we will move further. I think we should move further now. Okay. If you have any doubt, you can comment, you can chat, write in the chat box. Moving further. So now the moment of inertia of continuous bodies, can you feel that these things are just similar to the center of mass situations? Every with the formula is different, that's another thing, but the things are similar. So I will not go in deep details about the calculation of these moment of inertia now. You need to memorize these formulas. So how the moment of inertia of continuous bodies are calculated? We know that moment of inertia is I is equals to sigma mr square. This is for the system of particles. Now, if we have continuous body, then moment of inertia can be written as this summation sign will convert to integration dm into r square. I'm not going in deep discussion about this thing, that because I have already discussed such things in the class of center of mass when we have discussed the center of mass of continuous bodies. So today I am not feeling that there is a need to discuss. If you have doubt, you can ask me. Otherwise, the thing is clear. What is dm? Dm is what? Mass of the small element. R is the perpendicular distance from the axis. From the axis. I think this is clear to you. Now you will need to learn some of the moment of inertia of continuous bodies. I will make you learn. First of all, one thing that is to be understood very clearly whenever you are dealing with the moment of inertia. The first question that should come in your mind is what is the axis? About which axis we are going to calculate the moment of inertia? That is going to be the first question in your mind. You will ask yourself, ask your teacher, whoever is asking the question, that what is the axis? So the first situation in front of you is thin rod. So first question is about which axis, sir? So axis I am giving you. Suppose the rod is placed along the x-axis. In both the diagram, rod is along the x-axis. And do you notice that in this diagram, axis is in the y-axis, and in this diagram, axis is along the z-axis. This is y, and this is z. But the main thing is that axis is passing through the center point or the midpoint of the rod. Axis is passing in both the situation towards from the midpoint of the point. This is L by 2, this is L by 2. This is again L by 2, this is again L by, and the mass of the rod in each case is m. Then moment of inertia of the rod in both the cases will be m L square by 12. You need to remember this actually, or I think you have derived it in your class 11 sessions. When you have attended your classes, you must have derived that equation. So there is no issue with that. So moment of inertia is ml square by 12. About which axis? About an axis passing through the center of the rod, passing through the center of the rod and perpendicular to it, and perpendicular to it. Is this clear? I have mentioned all these in a table. Next thing that you need to remember, moment of inertia of a uniform ring. Again, one thing, you need to identify the axis. So the axis in this situation is axis passing through the center and perpendicular to the plane of the ring. This is another difficult situation for you, I think. For example, ring is like this. This, my hand is like a ring. Suppose this is a circular ring, and the axis is what? Passing through its center and perpendicular to it. This is the axis. Passing through its center and perpendicular to it. This is what our axis is. I think this is clear to you. So what is the moment of inertia of this system? Moment of inertia of this system is I is equals to m r square. I am again repeating my words. Axis is very important. If you change the axis, moment of inertia will change. That's for sure. So about this given axis, moment of inertia is mr square. Similarly, there are various bodies, like there is a hollow cylinder, solid sphere, solid cylinder, disk. You need to remember those formulas, those moment of inertia about a given axis. So on the next screen, there is a table that you need to remember. Just take a screenshot or whatever you want. At least few of these you should remember. Like this one, and all these. This one, these, and these. The moment of inertia of the disk. Disk has moment of inertia mr square by 2. Ring has moment of inertia mr square. Cylinder has moment of inertia mr square by 2. This is hollow cylinder. Clear? You need to remember these things. Keep in keep these things in mind, because on the next slide we are going to use these formulas actually. I think this is clear to you. Now moving further. I have You can pause the video here, or you can I have stayed here for a long time. You can actually write these things, because we will use these situations. Solid sphere. Solid sphere has a moment of inertia 2 by 5 mr square, and hollow sphere has a moment of inertia 2 by 3 mr square. Clear? Here r is what? Radius. Okay. Now, there are few famous theorems to calculate moment of inertia of continuous bodies. First theorem that we are going to study is parallel axis theorem. Now listen to me very carefully. What does the parallel axis theorem say? Suppose Just suppose we have a body. I am not drawing a typical body. I am drawing a simple body like a rod. This is a rod, and we have seen the moment of inertia of this rod about the axis passing through the center. We know the moment of inertia of the rod about this axis. Can you see that this axis is passing through the center of mass of the rod? Listen to each word very carefully. This is the axis which is passing through the center of mass. Let's suppose the moment of inertia of the body about this axis is ICM. So first thing is, what is ICM? ICM is the moment of inertia of the body. I will mention it. I will mention it later. Now, what I can say, suppose there is another axis which is parallel to the previous axis. Consider another axis which is parallel to the center of mass axis, and the distance between these two is d, and the mass of the body is m. Mass of the body is m. So the parallel axis theorem says moment of inertia of the body about any axis which is parallel to the ICM is equals to ICM plus md square. Now I will explain it to you. I know that you are getting confused with all these terms. Let me explain it to you. Suppose you have a body and you know the moment of inertia of the body about an axis which is passing through the center of mass, which is passing through the center of mass. What is required? You need to calculate the moment of inertia about an axis which is parallel to the previous axis. Have a look at that. This is the axis passing through the center of mass, and there is another axis which is parallel to the previous one, separated by a distance d. Then moment of inertia will be ICM plus md square. But condition is that both the axes must be parallel and one must pass through the center of mass. Clear? Clear? I will move further. पैरेलल एक्सिस थ्योरम में आपको क्या याद रखना है कि जब भी हम पैरेलल एक्सिस थ्योरम अप्लाई करेंगे, देन दोनों एक्सिस पैरेलल होनी चाहिए. बोथ द एक्सिस मस्ट बी पैरेलल टू ईच अदर. सेकेंड थिंग, one of them, at least one of them, should pass through the center of mass of the body. Only then we can apply these parallel axis theorem. Clear? Okay. Now moving further. There is another theorem, perpendicular axis theorem. Perpendicular axis theorem is again, one limitation of this theorem is that this theorem is applicable only for the two-dimensional bodies. Two-dimensional bodies, you can say, for the planar bodies. Applicable in plane bodies. Plane bodies, like example of plane bodies are, for a disk, it is valid. It is not valid for a sphere because a sphere is a three-dimensional body. It's not valid for a sphere. It is valid for a ring, but not valid for a cylindrical body. It is valid for a rectangular sheet, but not valid for a cube. So it is valid only for the bodies which have only area and not have any volume in it. I think it is clear to you. First thing is clear. Now, what does the theorem state? Let's take a simple example. I am drawing a disk. I am drawing a disk. Have a look at that. Let's suppose this is a disk, and this disk is placed in the XZ plane, in the horizontal plane. Can you see the horizontal plane? One thing is, it is placed in the horizontal plane. Now, notice few of the axes. This is a disk actually. This is what? Disk. In which plane? XZ plane. XZ plane is what? Horizontal plane, like this. And there is a axis like this one. This is the diameter actually. And there is another axis which is again a diameter. Some of you may ask, sir, this is not looking like disk, it is looking like a ellipse actually. No, I have drawn a disk, but to draw the disk in the XZ plane, I have tilted it like so. That's why it's looking like a ellipse actually. It's not an ellipse, it's a disk, circular disk as actually. So don't mess these things in your mind. Okay. So have a look at these two axes. One, this is along x-axis, and the another axis, this is in the z direction. Don't confuse it. Don't confuse with x, y, z. I think it will hamper your not understanding. Don't confuse it. These are the two diameters. Just have a look at that. Now, I am drawing another axis which is perpendicular to both of these. Which is perpendicular to both of these. Now, can you see the three axes? Out of these three axes, one important point is all these three axes are coinciding, or you can say they are intersecting each other. So first point is all three axes are intersecting at the same point. Remember all these points, otherwise you will not be able to apply the perpendicular axis theorem. Now, out of these three axes, two are in the plane of the body. Two axes are in the plane of the body. Like this is axis 1, this is axis 2, and this is axis 3. So axis 1 and axis 2 are in the plane of the body, and axis 3 is perpendicular to the plane of the body. Let's suppose this is the body. This is the body. Can you see that this axis is perpendicular to the plane of the body? This axis is perpendicular to the plane of the body. This is in the plane of the body. This is also in the plane of the body. So that's what I am saying. So what is the formula for perpendicular axis theorem is I3 is equals to I1 plus I2. Now you need to remember what is I3. I3 is the moment of inertia about an axis perpendicular to the plane of the body. And these two axes are in the plane of body. And this is perpendicular to the plane of body. Now we need to apply these things very quickly. Remember one thing, I3 is what? I3 is equals to I1 plus I2. You will remember what is I3. I3 is the moment of inertia about the axis which is perpendicular to the plane. Now we will do it with by some questions. Let me explain it to you further. Let's solve the question actually. It will take a lot of time actually. First question on your screen is, you can take a small amount of time. Find the moment of inertia of a disk about an axis passing through its diameter. Passing through its diameter. The question is very simple. We have 3 or 4 minutes actually. Suppose this is a disk. The moment of inertia of the disk we have seen in the table about an axis passing through the center and perpendicular to its plane is known as mr square by 2. Is known as mr square by 2. And we need to calculate the moment of inertia about the diameter. Can you see that diameter is this? Diameter is this. Diameter is this. Clear? I think clear now. So let's suppose identify the axes which are in the plane of the body. Can you say that this is in the plane of the body? So let's suppose this is first axis. This is also in the plane of body. This is second axis. And the third axis is what? Which is perpendicular to the axis. So this yellow, the original axis is perpendicular to the plane. Again, by symmetry, can you see that axis 1 is the diameter, axis 2 is also a diameter. So what I can say, I3 is equals to I1 plus I2. And these I1 and I2 will be equal. These I1 and I2 will be equal. Why these I1 and I2 are equal? Because these are the symmetrical axes. This is the diameter. This is also the diameter. So they are similar. So I will write as I3 is equals to 2 times of I1. So I1 is I3 by 2. And what is I3? I3 is the moment of inertia about that given axis that we know, that is mr square by divided by 2. So I is mr square by 4. I think it is clear to you. You can ask whether there is a doubt. If there is a doubt, you can ask. Otherwise, there is another question on your screen. This is a good question actually. No, this is not a good question. You can do it in the homework. This is very simple question. Can anyone answer it within 1 minute actually? Can anyone? Any one of you can answer. YouTube family can also answer. The persons watching on the YouTube can also answer. I can see that there are a lot of persons watching on the YouTube now. So they can also answer. Do it, do it, do it. I think time is just running out. So I will end the session. Otherwise, anyone just reply which theorem you will use. Okay. So right now I am ending the session. What we have studied parallel axis theorem and perpendicular axis theorem and moment of inertia of continuous and particles. Okay. He is saying parallel axis theorem. Very good. Parallel axis theorem will be applicable here. And you will get the answer as ml square by 3. This will be your answer. If you solve it, you will get the answer ml square by 3. So I am ending the session here. Till then, bye bye.
Hello, student. So today we are going to cover the last third topic of the ray optics, that is the optical instrument. Basically, in first two lecture we had covered that in first lecture that is reflection phenomena, and in the second lecture that is the refraction of the light. In the refraction section, we already covered about refraction to plane surface, then refraction to curved surface. After that, we understand the concept of the lens. Then we also understand some conceptual clarity of the prism. Okay, so here we are discussing about the optical instrument, which type of optical instrument we are going to use generally in physics and in other applications also. So today we are going to take a overlook about the optical instrument. So before going to cover optical instrument, let's take the cover of overlook which type of subtopics we are going to cover in today's session. Right? First is our human eye, and we know that the human eye is also acting like as a optical instrument that provided by God. That is the natural optical instrument. Second one, that is the defect related with the eye. That is the eye defect. Third is the visual angle, and the next one is the simple microscope. As we know that since our childhood we are going to use simple microscope. This is nothing but that is the convex lens, and after that, in order to get more angular magnification, we are going to use compound microscope. Next topic is the telescope. Whenever we want to see that distant object, then we have to use the refracting type of telescope. Actually, there are two types of telescope in our syllabus, and basically here we are going to cover refracting type of telescope. And last one is the resolving power. What is the resolving power? As any optical instrument that is associated with some resolving power, so we also discuss about the resolving power. So first, we are going to understand what is the human eye. As we know that human eye, in human eye there are two type of points are defined, and we know that if we talk about the human eye, so there are some physical characteristics how human eye is made. So we can say that this is a type of lens that is provided behind the retina, and this type of lens giving a flexibility by giving a point, giving a muscle that is known as the ciliary muscle. Ciliary muscle provides a flexibility to eye so that it can change the image position in order to form the clear image at retina. As we know that the retina is a back surface where the image is formed by the eye. In order to form the image in a retina, ciliary muscle play very important role. Suppose if we consider that the object is placed at near point. What is the meaning of near point? Firstly, we have to understand this point. Near point is nothing but this is the distance from our eye at 25 centimeter where we can see clear image. We can see clear image. It means image is formed at our retina without using any instrument. So such type of distance from human eye where we can see the clear image, that point is known as the near point. So near point is also known as the least distance of distinct vision. It means we can distinguish the object, we can differentiate the object that is a distance from our eye, and we can say that this distance is normally taken for a human is 25 centimeter. So here, if we consider that the object is placed at near point, that is the least distance of distinct vision, so what will happen? The ray coming from this object, and after the refraction, as we know that the eye lens having converging characteristics, so we can say that after refraction through this lens, that is the crystalline lens, the ray must be focused at the retina. ray must focus at retina, we can say that we can see the clear image. Here, another point, that is the 4 point is also defined. 4 point is normal eye defined as infinity. It doesn't mean that in a finite distance, that it is a relative value. We can say that when object is far away from our eye and we can see the image of that object, clear image at retina, that is our eye. For our eye is defined as the 4 point, and generally this distance is taken as infinity. So we can also mention here what is the note, what is the use of the ciliary muscle that can change the curvature of our eye lens so that a sharp image is formed. Next one, that what is the defects that associated with human eye? As if we are talking about our human eye, what we generally observe is some person having glasses and they are using some type of positive power of lens, and another person having some type of defect, they are using some negative power of lens. Then what is the meaning of the positive power and negative power? As we know that the power of lens directly related with the focal length. If we talk about the power of lens, that is inversely related to focal length, and we know that the focal length of converging lens is positive, so power of converging lens is also positive. So we can say that the power of convex lens is positive, power of concave lens is negative. The first defect that I am going to discuss here, that is known as the myopia, and it is also known as nearsightedness. What will happen in nearsightedness? A particular person not able to see the far object. It means what will happen here? The image is formed before the retina. That's why he or she can't see clear image. This type of defect is known as the myopia. Actually, what will happen if we suppose that this is our human eye. Suppose, guys, this is our human eye, and this back surface is known as, suppose this is retina. Okay, if we consider that ki somewhere object is placed at this point, then what will happen here? The image formed by our eye lens, that is not formed at retina, but it must form before the retina. That's why he or she can't able to see clear image. Only one should only see clear image if the clear image is only noticeable when the image is formed at retina, but image is formed before the retina, it means he can't able to see the image. And what we have to do to correct this type of defect? What is the remedy of this type of defect? It means if we use a diverging nature lens, so that the ray must converge before the retina. If it ray converge after or at the retina, so we have to use a diverging type of lens, so that it ray must meet at a retina. So in order to detect, in order to, we can say, correct this type of defect, we can use a concave lens. If we use concave lens, we know that the concave lens having a diverging characteristics, it had a property to diverge the ray. When ray is passing from this diverging type of lens, then what will happen, guys? The ray is not meeting at this point, they will meeting at this point, and finally what will happen? Finally we can see that the image is formed at somewhere retina. So by using the concave lens, we can say that we can say that myopia can be removed, right? The second is the hypermetropia. Hypermetropia is also known as the farsightedness. what will happen in this type of defect? The final image is formed beyond the retina. That's why we can't see image of near object. Generally, this type of defect, what is happen? We can't able to see the clear image of near object. If we consider this type of defect, we can say that in this type of defect, if we consider this is our human eye, guys, this is our human eye, and say if object is placed somewhere at this point O, the ray is coming from O, not meeting at retina. This is our retina. This surface, that is the back surface, we can say this is the retina. The ray is meeting somewhere beyond the retina. Then what we have to do? We can't able to see the clear image. So we have what we wish. We wish the final image is formed at retina. So we must want to converge the ray at retina. In order to converge the ray at retina, we have to use a convex lens. Between object and eye lens, we are going to use a convex lens for a given focal length, so that the ray that will converging at this point I, they must be converging at retina. So by using the convex lens, we can say that we can correct the hypermetropia also. So in hypermetropia, we are going to use the convex lens, and we know that the convex lens having the positive focal length. So we can say in this type of lenses, the power is positive. The power is positive. If one should carry positive power lens, we must say that the person must possess hypermetropia. And the similar manner, we can say that the concave lens having negative focal length, that power must be negative. So we can say that if one person having myopia, so it must carry to correct the myopia, that is the concave lens. So concave lens is used in case of myopia to remove the myopia, and in the case of hypermetropia, if one should try to get remedy from the hypermetropia, he must use convex lens. The another type of defect, that is the presbyopia. What is happen in the presbyopia? This type of defect is generally observed in the elderly person. We can say old age person. And in this case, what will happen? The near point of eye of the old age person is shifted away. That's why he can't able to see the object. So in this type of defect, this is generally happened a person which already suffered anyone myopia or hypermetropia. So this is generally observed in old age person. And to remove this type of defect, we are going to use, that is bifocal lens. We can say that bifocal means that is characteristics of concave and convex both. That is next one is the astigmatism. What is happen in the astigmatism? That is not a clear image. That is the distorted type of image is formed. So in distorted type of image is formed, that is the defect is known as the astigmatism. And to remove this type of defect, and we can say what is the remedy of this type of defect, we once should have used the cylindrical lens. Actually, guys, in previous JEE mains, the direct question asked with the eye defect. So we have to very careful about when we are study about what is that eye defect, and one should know what is the corrective lens for given type of defect also. Let's move further. Visual angle. If we wish to calculate what is the magnification of any optical instrument, before going to learn the angular magnification, we must do the concept of the visual angle. Right? What is the visual angle? That is angle formed at our eye. We can say that the visual angle, and visual angle sometimes also known as that is the angular size. Correct. So if I am talking about ki this is, suppose this is a human eye, and suppose that ki one object that is placed at a distance, we can say that ki if object is placed at a distance x1, it must subtended any angle on human eye. Say this angle is alpha 1. If we move the object from our eye and say if we move the object at a distance x2, say this distance is x2, correct? Then what will happen? Then what we observed that in this case angle subtended at our eye, that is alpha 2. It is very much clear in this diagram, guys, that alpha 1 is greater than alpha 2. What is the meaning of this? As object is moved from our eye, the angle subtended by object at our eye, that is continuously decreasing. If angle is decreasing, we can say that we can't see clear image, right? That is the case. We can also describe that. Suppose if we consider that this is our human eye, right, guys? And if we consider that suppose this is a object AB, this is a object AB which having a distance from I, say this distance is x1, and this makes an angle, say that alpha 1. If we move this object from our eye, say this distance is AB again, that height of object is not going to be changed, but the distance from the eye is going to be changed. In this case, the angle subjected by object in the human eye, that is decreasing. Say this angle is alpha 2. So we can say that what is the problem here? If we see the distant object, we can't see clear image because the visual angle formed by object in our eye decreases, right? So if we want to clear image, if we want to see the clear image, then what we have to do? We can also write down this visual angle by using tan theta or tan alpha. That is nothing but perpendicular upon distance. Okay. So what is the reason behind to decrease this visual angle? There is the two possibility. One, if we increase the distance, then visual angle is decreases. One, this visual angle is also decreases, guys, if object size is very small. If object size is very small, so we can say that the visual angle formed at our eye, that depends on two parameters. One is the size of object and another is the distance of object from our eye. Okay. So in both the cases, we have to very much careful what condition is given here. If I am talking about the celestial body, that is the moon, star, and some other planet, in this case, the distance x is very large. Because of this, alpha is very small, so we can't see the clear image. But what will happen in the case of virus, bacteria, in such type of cases, because of the size of object, we can't see clear image, right? So in order to see the clear image of the small object, we have to use an instrument, and that type of instrument is known as the microscope. And that is the another thing. If we can't able to see the clear image, not because of the size of object, because of the distance of object from our eye, and this type of phenomena, when we have to use to see the distance object by using a such type of optical instrument, that is known as the telescope. So we have to very much clear what is the difference between microscope and telescope. Microscope is used for to see the small size object, but telescope is used for the distant object. Correct? I hope this is clear for you. Now we are going to study about if there are some bacteria, some virus are present. We know that such type of virus, something like a COVID coronavirus is also going on. Then what we have to do? In researcher, they want to see the size, and because after seeing the size, they can comment the characteristics of the virus. Okay. So in order to see the small size of virus and bacteria, they must use simple microscope. That is the first microscope, not simple microscope. In today world, they are using some advanced type of microscope, right? Which have a higher magnification power. So firstly, we have to understand how simple microscope is functioning, and on the basis of simple microscope, by some updation and some advancement on the simple microscope, we can also study the compound microscope. So if I am talking about the microscope, so how we can define the microscope? Microscope is nothing but optical instrument which magnify a small object. As I discussed with you, when we can't able to see the image of a small object, so then we have to use the microscope, right? So here the term that is very, very important in order to understand the nature and the properties of microscope, so that we can solve the numerical of microscope and telescope also, that is the magnification of the simple microscope. So firstly, we have to understand the meaning of magnification. This is not a linear magnification that we earlier studied in the case of the mirror and lens, right? This type of magnification is known as the angular magnification. And what is the angular magnification, guys? Suppose if an object is placed, if we consider a lens, generally simple microscope is nothing but a simple convex lens. If we are using a simple microscope, that we can say that we are going to use that is convex lens. And if we want to see the magnified image in large image, then what we have to do? So one can tell that, sir, if we want to use magnified image by using the convex lens, then there is a one condition, and we have to put our object between the optical center and the first focus. Am I correct, guys? Yes or no? We can say that, suppose, don't say anything, there is a type of microscope, we are just using a convex lens. If you are using the simple convex lens and you want to see a magnified image, and you want to see the image that is erect, because we want to see a bacteria, we want to see bacteria that is the same orientation, right? That is object the same orientation we also want from the image also. So in order to see the erect and magnified image, we know that there is one condition. Whenever object is placed, that is the first focus and optical center of the convex lens, we can say that we always see a magnified image that is virtual in nature. Correct? But image is magnified. Once image is magnified, we can see that a bacteria which having a size in nanometer, maybe a microscope can live in large size in the millimeter, in micrometer. That it depend upon the magnification of the microscope, how much extent it can enlarge the size. But we can say that whenever object is placed between the first focus and optical center, then what will happen, guys? We can say, in order to draw the image, we must choose any two ray. If we pass one ray passing through optical center, the ray is passed without any deviation. And one ray, if we pass that is parallel to principal axis, we can say that after the refraction, it must passing through the second focus, that is the main focus of the convex lens. We know that these two rays not going to be meet after refraction, because they having some separation, that is the diverging type of nature. Then what we observed that, guys, if we present some here, suppose this is our eye. If we say, suppose we are going to use some other color, suppose this is our eye, guys. If we see from here, then what we see that in order to get the image, we must extend this ray in this direction and this ray in this direction. Correct, guys? And we can say that at a given point, the ray that is that is extended in this direction, they will intersect. They will appear to intersect, not exactly intersect, because we form a virtual type of image. We can say this is a dash. We project in downward direction. We can say this is the B dash. In order to, we can see that the size of the height of object we consider h naught. In this case, the height of object is large. That is the simple concept of the simple microscope. As name is referred at simple, so this is very simple. I hope this is clear. This is the functioning. Before we understand how this is working and what is the magnification here. Guys, if we want to understand the magnification, we must know the concept of the visual angle and how this is defined. That is the visual angle formed by the final image divide over visual angle formed by object kept at distance d. Kept at distance d. What is the meaning of d? Distance of distant vision. Distance of distant vision. So if we consider that final image, this is our final image, correct? And suppose this is our eye, and we consider our eye at this point also, correct? So we can say that the height of this object is AB, and we can say this image is A dash B dash. Then what is the angle subtended by image at our eye? We can say that if this angle is guys beta, so by the vertically opposite angle concept, we can say this angle is beta. So we can say that the angle subtended by image at the eye of the eye lens observer, that is the beta. So visual angle formed by the final image, that is nothing but beta, and the angle formed by the object when it's kept at distance d. What is the meaning of? We can say if this angle is alpha. If we see that if this angle is alpha, what is alpha? Meaning of alpha is we are not going to use any type of instrument. We simply place the object at D, and then we see what is the angle subtended by that object in our eye. That is our alpha. So we can say that alpha is angle subtended by object without using any type of instrument. We can say we see the object by our naked eye and place the object at the D. I hope this is clear. So in order to see the sir, if this is our eye, correct? If this is our eye, and if we place the object at D, suppose this is a bacteria, and if we place the bacteria at a distance D, correct? Then what is the angle subtended by that bacteria in our eye? That is our alpha. We are not going to use any type of instrument here. Correct. So in this manner, we can define the alpha. Whole ray of this, as I already discussed in the previous lecture, we take one assumption. We only consider the paraxial ray and the ray that is very close to principal axis. That's why we can say that the angle formed by the ray on the optical axis, that is the principal axis, is very, very small. And whenever such type of situation has come, we take one approximation. Whenever beta is given, we can write down this tan beta, and in place of alpha, we can put the value of tan alpha. That's why we can going to use our trigonometry. Correct. So here we can say that what is our tan beta? What is our tan beta, guys? We can say tan beta. What is our tan beta? Tan beta in this triangle, we can say that nothing but in the larger triangle, we can say that tan beta is also involved. In smaller triangle, tan beta is also involved. But we know the result in the term of height of object, that is common in both the cases. So we are going to choose a smaller triangle. Here we can say tan beta is nothing but AB upon, in smaller triangle, say this is the O. We can say in triangle ABO, that is nothing but AB upon U. that opposite direction of incident of right, we can say this is nothing but minus u. Correct. Say this equation is 1. And the second, we have to also find out the value of the tan alpha. So here we can say that tan alpha is nothing but we can say that is AB upon minus D. Right? So guys, if we put the value of beta and alpha here in equation 1, what is the magnification? This is the general formula of the magnification. We are not going to considering any special case. That is nothing but AB upon minus U divide over guys AB upon minus D. What we observe here guys, this will become minus and minus cancel out D upon U. D upon U. One thing we can also mention here is that this lens that is placed near to I. So why we can't say this is the I lens? Correct. So this type of lens we can also say that there is only one lens and that is placed near to our eye. We can also say that this is behaving like as a eye lens. Okay. In further discussion, when there are more than one lens is involved, we can say that the one that is placed near to eye lens, another which is placed nearer to object, that is the objective lens. That's why we can say if this is eye lens, so there is no problem. Correct. So in this manner, we will able to get that is the expression of the magnification in the case of simple microscope, and that is very, very important formula D upon UE. Correct, guys? D upon UE. So this is the general expression, and we are not going to take any special approximation in this formula. Okay. So what will happen? Generally, two types of cases is possible in this type of magnification. Whenever we put the object, we want the what we want. If we want the image of final object at the D, that is the case 1. And whenever we want that final image is formed at a 4 point. So let us consider the case 1. What is the case 1? Say this is the equation number 2. When final image, we can say when final image is formed at a near point, in this case, what will happen? Suppose if put our object at 25 centimeter and we continuously watch the object for the 4 to 5 hours, 6 hours, for a long hours, what will happen? We feel that I stress in eye, I strain in eye. If we put our book at 25 centimeter and we continuously study for a long time interval, what we feel? We feel I strain in eye. So sometime when final image form at near point, and we know that the near point is known as the distance of distant vision. This case is also known as the case of the strained eye. And in this case we will get maximum magnification. So sometimes this case also asked in the terms of the maximum magnification. In the terms of it is asked maximum, that is maxi magnification. Right, guys? So what will happen here? If we want to see that the final image is formed at D, then what we have to do? We know that if this is our lens and we want that final image is formed at D, in order to form that final image at D, we can say that we want that final image, that is image distance VE, this will become equal to D. Correct, guys? Correct. So if we want final image at D, we can say this is our final image. So if we apply lens formula for the eye lens, we can write down that 1 by V minus 1 by U equal to 1 by F. We know that if we want final image at D, if we put the value with sign, so what we put here, we can see V equal to minus D, U equal to minus U, and we know that the focal length of that is the converging or convex lens is positive. That is F equal to plus FE. if we put this value here, what we will get here, that 1 upon minus d, this will become minus and minus, this will become positive, that 1 upon fe. In this case, if you calculate the value of 1 by ue, this will become 1 by d plus 1 upon fe. If we put this value in equation number 2, what is the magnification? This magnification, that d into 1 upon ue, the place of 1 upon ue, we can put 1 upon d plus 1 upon fe. After solving this, we can say this is nothing but d upon fe. This is the value of magnification whenever final object is formed at distance of distinct vision. Correct? We have to very much clear this is not a general formula, but it's the specific formula when we want that the final image is formed at D, so that our magnification will get maximum. We can see that this term is added with 1. So we can say that this magnification is the case of the maximum magnification. So sometimes this magnification is also said that maximum magnification of in the case of the simple microscope. Correct. What is the case 2? If one should try to make final image at a far point. What is the far point for human eye? We can say that is the infinity. So we can say if final image is formed at infinity, right guys? If final image is formed at infinity, so we can say that in this case, must say that in this case the object is placed at the first focus, so that final image is formed at infinity, that v equal to nothing but infinite, u equal to minus ue, and we can say this is the convex length, so focal length will become that is plus fe. Again apply the lens formula for the eye lens. We can say that this is nothing but 1 by v minus 1 by u equal to 1 by f. And in this case, if the put the value here infinity, we can say this will value 1 upon ue equal to 1 upon fe guys. Correct. See this value. If we again replace 1 by ue in the equation number 2, what we will get? That magnification in this case, that is d upon fe. What one thing we observe here, there is two possibilities. Either object is placed at near point, either final image is formed at near point, either it formed at the far point. Between them, there are infinite possibility, right? So we can say that our magnification that lie that between d by fe and 1 plus d by fe. Why between d by fe and 1 plus d by fe? Because we know that this is the case when a human can see clear image at distance of 25 centimeter, we consider that distance for the safety point of view. And this case, we also consider that in the extreme case when the final image is formed at the infinity and final image is formed at the near point. Correct. So we can say this value is lesser than the value we obtained in previous case. This is the magnification. We can say that this is the minimum magnification. But when the final image is formed at infinity, so we can say that there is a relaxed for human eye. There is no type of strain is generated in human eye. This type of magnification is also said that in the case of the relaxed eye. This type of case is also known as the relaxed eye. Correct, guys? So we have to very much clear what is the relaxed eye and what is the strained eye. Sometimes it is also asked what is the magnification and what is the range of magnification. So we can say this is the minimum magnification d by fe, and what is the maximum magnification? 1 plus d by fe. So our magnification will lie between d by fe and 1 plus d by fe. Equality sign must hold because in the case of far point and near point, it must hold the inequality also. If anyone asks to me what is the angular magnification of the simple microscope, we can say that the general formula. When nothing is mentioned, we are going to use general formula. But if somebody asks to me what is the range, we can say d by fe That is d by f is the minimum and 1 plus d by f is the maximum value. Let's move for some more modified type of microscope if we want more magnification. But there is some limitation with simple microscope. We only see in the case of simple microscope, in case of the simple microscope, we only limited in the magnification up to 10, correct? Not more than 10. But if we want to more precise, we want to see more precise image of a small type of object, that is the bacteria and virus, then what we have to do? We have to use some more accurate type of microscope in order to extend the accuracy of the microscope. In order to improve the magnification of the microscope, we are going to use multiple type of lens, correct? So this type of microscope, that in order to get maximum value of, and we can say that more value of magnification, that is known as the compound microscope. The next one is our compound microscope. As I discussed, there are more than one lens we use. We can say कि the lens which is placed nearer to the object, that is known as the objective lens, and which is placed that is close to eye, we can say that is our eyepiece or eye lens. Okay. Our intention and our goal is very much clear. We want to see magnified image. Finally, we want to see that enlarged image. And we also know what is the condition in the case of convex lens, and which condition we will get magnified image whenever object is placed between the first focus and the optical center. Okay. And so we can say that the lens which is closer to human eye, that is larger in aperture as compared to objective lens. Okay. One should know what is the reason behind this. Okay. What is the logic behind it? Why we are going to choose larger aperture eyepiece lens as compared to objective lens? So we can say that if the aperture of this lens is more, so we can focal of this lens is also more. If focus of this lens is also more, so there is a possibility that suppose if focus of this lens is lie in this point, say this point is, say that is this point is f1, correct? So because of larger aperture, we can extend the range of f1. That's why the image formed by the objective lens that must beyond the f1. If image of objective length lie beyond the point f1, that is act of object for the eyepiece lens, and we require this situation. We need this type of situation, that image form for eyepiece lens between the optical center and first focus. That's why we can form a magnified image. Okay. Suppose if we consider small size of eyepiece lens, then what will happen? Then the focus of this lens lies somewhere here, this point, and this image beyond the focus, and we can't get magnified image. I hope this is clear for everyone. Why we choosing here larger aperture of eyepiece lens, so that we will get enlarged final image. We will get final image greater in size. Correct. So what will happen, guys? Let's we consider that if object is placed somewhere, AB object is placed to this lens, and this lens is known as the objective lens because it is placed nearer to object. If you want to draw the image, what we have to do? We required at least two rays. So if we consider one ray is passing through the parallel to principal axis, and that after refraction to objective lens, it must focus to focal point. If one ray we must pass it through optical center, so we can say this is the point where we will get inverted image A dash B dash. And the distance between image is managed in such a way that the final image is that the image formed by objective lens that must lie between first focus and optical center of eyepiece lens. Correct. So in this manner, we have managed the distance by flexible tube. That we can say that is the length of tube. That is length of tube is managed in such a way so that this image is formed between the f1 and optical center of eyepiece lens, and we can say that this is nothing but it is the previous case what we have discussed in the case of compound microscope. This object is lie here. We can say we must draw two rays in order to get the image. One ray is passing in this manner, another ray is passing this manner. There is no possibility to meet in this direction, so we can extend this ray in backward direction, and we will get a enlarged image, that is the A double dash B double dash. And we can see that the enlargement of image that is formed by the eyepiece lens, that is more than size as previous case, because we are using two lenses. This lens is also enlarged in size, and this lens is also enlarged in size. We can say magnification is multiplied because of we are going to use two lenses. Okay. So here what we have to say that in order to find out the magnification, or we want to write down the magnification, what we can say directly, this lens, this complete compound microscope is made by two type of lens. So we can say magnification is always written is the product of individual magnification. If we want to write down the magnification of the system of lenses, what we have to do? We have to multiply the magnification of the individual lenses. So we can say this is our objective lens. Say this is the objective lens, and this is our eyepiece lens. Earlier we can say this is behaving like a simple microscope. We can say this is magnification of the simple microscope. Okay, guys. If we can say that what is the magnification of objective lens? This is the linear magnification of any convex lens, that is nothing but V by U. Correct. So what is the V for objective? We can say V naught. What is the U? That is the U naught. Correct. This distance is nothing but U naught, and the image formed by this objective lens, we can say this distance is, we can say that this distance is nothing but this distance. We easily say this distance is V naught. This is our V naught. Correct. So we can say that, guys, V naught upon U naught. If we put the value that in we will get in the previous case, that is the magnification of the simple microscope. What is the magnification? We can say nothing but D upon UV. So in this manner, we will get magnification of compound microscope in single line. Okay, by using the concept, this is behaving like as a normal lens. Write down the linear magnification of this. This is the our simple microscope. What is happening in simple microscope? At a simple convex lens, this is the magnification of this. Correct. Now we are going to consider two cases. Okay. So let's consider the case one. Let's consider the case one. The case one is the when final image is formed at near point. So we consider if final image is formed at near point. Correct, guys? What is the meaning of near point? We already know this is the case of maximum magnification. This is the case of maximum magnification, or we can say that in this case we feel some stress, or we can say this is the case of the strained eye. Correct. So in this case, what will happen, guys? We can say that the general formula of the magnification V naught upon U naught, that is D upon UV. If we consider that if we put the value of UV in order to get final image at near point, if we consider eye lens, guys, we can say if this is our eye lens, and if we want to form final image at near point, we can say V is nothing but in this case minus D, and U is nothing but minus UV. And if we apply the formula, guys, if we apply the formula, that we can say that in this case our final image, that is A double dash B double dash, that is formed at D. Correct. If we apply the length formula for the eye lens, 1 by Fe equal to 1 by V minus 1 by V. Correct. If we put the value here 1 by Fe, what we have to do? We just find out the value of 1 by UE and put the equation number 1 so that we will discuss the case. What is value here? That 1 by V we can put 1 upon minus D, and in place of 1 by UE we can put the value of UE, that is the minus, again this will become plus UE. So in this case, what is the value of UE? We can say nothing but 1 upon Fe plus 1 upon D. In this case, we can put this value here, and this will become magnification, that V naught, U naught, and this will become 1 plus D upon Fe. There is no need to do this because we already know that what is the magnification of simple microscope in the case of when final image is formed at near point. So we can say that we already know the magnification of simple microscope is 1 plus D upon Fe. If we put this value in directly in place of this value, we will get this result. Correct, guys? If we consider the case 2, when we want that final image is formed at a 4 point, in order to 4 point, we can say that the image formed by the objective lens must form at the focus of the eye lens, so that final image is formed at 4 point. And in this case, we have to put that V equal to nothing but that is minus ka infinite. So after putting this value, we can say that 1 upon Fe equal to 1 upon, we can say that this will become 1 upon UE, and in this manner the magnification, this will become V naught upon U naught, that D upon Fe. What we observe here, this is the minimum and this is again maximum. So we can say far point, that is the case, we can say that this is case of the minimum magnification. Minimum magnification, and we also say that, guys, in this case, we are not going to feel any type of strain. This is the case of the relaxed eye. This is the case of the relaxed eye. So in this manner, we can find out this value. What is happening sometimes? Sometimes tube length is also asked. What is the tube length? Okay. So tube length is nothing but that is the distance between objective and eye lens. We can say what is the distance between objective and eye lens. We can say this distance is nothing but that is distance. That's why we are using mod sign here, V naught, and this distance. What is the distance, guys? We can say that this distance is nothing but that is mod of UV. Correct? So we can say this will become mod of UVO plus mod of UV. This is length of tube. Sometimes what is happening, we consider approximation when object distance and not given. Then what we consider that we directly V naught is directly replaced by, guys, L, and U naught is replaced by F naught. So this formula will become, sometime approximation is also considered. This will become L upon F naught 1 plus D by Fe. In previous JE, I think in JE 2021, this type of problem is asked where V naught and U naught is not given, and suppose length of tube is given and you have to calculate the magnification, then we have to also very much careful about that thing. We can use L upon F naught 1 plus D by Fe. In this case, this is the case of the maximum magnification, and in this case, D upon Fe. Correct, guys? So in this manner, we can study all about all the cases about the compound microscope. This is the ray diagram whenever final image is formed at infinity. So we can say that the image formed by the eye, the image formed by the objective, that is the must lie on the eye of the, that is the focus of the eye lens. Okay. The case of the telescope, guys. If we discuss what is the telescope, as I discussed in starting of the class, whenever we are want to see the image of distant object like planets, stars, then what we have to do? What we have to do? This is not possible. This is not possible to magnify the size by the change the size of object. So we think if there is any possibility to increase the visual angle, we can see the object of the telescope. Then what we have to see by using telescope, the distance object is something like that, moving that away, moving towards our eye. That's why we can see the clear image. Okay. There is two types of telescope. Generally, there is two type of telescope that is given in our syllabus. That one is the refracting type and another is the reflecting type of telescope. Refracting type telescope having some numerical approach also, and in this refracting type of telescope you have to also calculate the magnification. That's why we consider here refracting telescope. In the reflecting telescope, there are two type of telescope. One is known as the Cassegrain, and another is the Newtonian. That is the Newtonian telescope. So this is only theoretical part, and only that is the Ray diagram is asked in this section, Cassegrain and Newtonian. So that is not much tougher part. So we are only discussing about refracting type of telescope. In reflecting type of telescope, any type of telescope, what is the use? We can say that is you want to see distance object, that is planet, star, etc. We can say that if we consider any star and rays coming from this star, correct, and the parallel ray is coming in such a way, so what we can see that, guys, after there is two type of lenses also used here. One is the objective and another is the eyepiece. What we observe here, the size of objective lens is more than at the size of eyepiece. It means aperture of objective is greater in size as compared to eyepiece. Why this is happening here? Because we want the rays coming for the distance object. If distance object is at far distance, so if lens is small, so lens is not capable to capture more and more rays. So that's why the clear intense image is not formed. In order to form the clear intense image, that intensity of image is so that we can see the clear image, we have to use a larger aperture of lens. That's why we can collect more and more ray. So in this, in order to get the intense image, we can say that we are using larger size of objective lens. So that is given that the objective is large aperture and large focal length, so that it can collect the more light from the distance object. If this is the distance object and say this is the angle made by the ray, incoming ray, that is the alpha, so we can say by symmetry this is the alpha, and after the refraction through the lens the image is formed at this point. In the same concept of that is the compound microscope we are going to apply it here. If the focus, we can say this is the parallel ray, and we know that whenever parallel ray is coming, if ray is parallel to principal axis, they must meet at focus. But if ray is parallel to itself, but not parallel to principal axis, they must meet at focal plane. This is nothing but this is a focal plane. We can say this is a focal plane, and this distance we can say that is the focal length of objective lens. Correct. If eye is present here, we can say in this case the final is object. The final image formed by the eyepiece lens, that is again enlarged in size. So what is the magnification of the refracting type of telescope? We again going to take the same type of approach we already taken in the case of the compound microscope. And we can say that if this angle, the angle previous case that is tan alpha, if angle is very small, so we can say tan alpha, and we have to calculate tan beta. That's why in order to write down the magnification, that is the beta upon alpha. Here alpha is not a distance when object is placed at D, because it is not possible to place the moon at D. Correct. So we can say that alpha is the angle subtended by object when we see the object. Correct. So we can say that this is the alpha. In the previous case, we can say this angle is alpha. If we consider that this is A, B, so we can write down here tan alpha is nothing but that a dash b dash. This is inverted. We can say minus a by b dash, and this distance is f naught. Correct. If we want to say that what is the beta, if we extend this here in order to make the angle beta, so what we can say that tan beta is, what is the tan beta from here? We can also write down the value of tan beta. That tan beta is also written with this triangle, guys. That is a dash b dash, and divide over, we can say that tan beta we can say minus ue. Correct. If we put this value here, what we can say that our magnification, this will become magnification, that this will become minus a dash b dash, and this will become minus ue here, that minus a dash b dash and upon f naught. In this manner, we can get the value. We can say our magnification will become fo upon ue. This is the general expression of the magnification. And what is the meaning of negative sign here? That final image is inverted. In case of the maximum magnification, again we consider that the case that final image is formed. Final image is formed at near point. Correct. If final image is formed at near point, so again we can say that we can apply the formula for the I length, that 1 upon f equal to 1 by b minus 1 by ue. Say this is the equation number 1. If only interested in magnitude, we can say fo upon ue. So we can say if we put ue here, that b equal to minus d here, we can say that what is the value of 1 upon fe? This will become minus d, and this will become 1 upon ue. So value of 1 upon ue, this will become 1 upon d plus 1 upon f. If we put this value here, therefore this will become 1 upon d plus 1 upon fe. After solving this, we can write down this f naught upon d plus f naught upon fe. This is the very important formula for the telescope when the magnification will get maximum. And this is also said that we can say that this is the case of strained eye. This is the case of strained eye, and when the final image is formed at the near point. Correct, guys? We have to always remember this formula. This is the case of the relaxed eye. Whenever final image is formed at infinity, this is also known as the normal adjustment. We have to very much careful when what normal adjustment asked. In the case of both, either in the case of the compound microscope, simple microscope, or telescope, the meaning of normal adjustment, that final image is formed at the 4 point. That final image is formed at the 4 point. So we can say that this is the formula, that fo upon ue, that is the general formula. The final image is formed at infinity. We can say that this, if we again apply the formula 1 upon ue equal to 1 upon fe. If we put for point that v equal to infinite, guys, so what we will get here, that magnification will become fo upon fe in the magnitude. So sometimes what will happen, it is asked in the problem, what is the tube length? What is the tube length? We can say that what is the tube length, guys, here? That is tube length, we can say that it does see nothing but fo. If we take the condition that is the normal adjustment, we can say fo plus fe. This is the value of the tube length. In general, we can say that tube length is nothing but fo plus ue. In general, if tube length is given, so we can say that tube length we can write down in general formula, that is fo plus ue. Correct, guys? This is the general formula of the tube length. So in this manner, we can calculate the magnification in both the cases, compound and telescope. So if we want to summarize what is the magnification for the microscope, if we consider that microscope, we can say that in case of microscope, we consider there is the 2 case. Correct. One is the simple and another is the compound. Correct. In simple, there is the 2 case. One is the general formula. What is the general formula? that is the d upon UV. There are further two cases. One is the object is image is formed at near point and another is formed at far point. So we can say that in this case formula will become 1 plus d by Fe. In such case d upon Fe. If we talk about the compound microscope, what is the general formula? Here the general formula will become, guys, what we can write down the general formula here. We can say that is the product of, we have to remember this formula, that is the product of objective into simple microscope, and this will become V naught U naught, and this will become D upon UV. We again say this will become for the near point or far point. In the near point, this magnification will become V naught, U naught, and 1 plus D upon Fe. For far point, this magnification, this can be written as V naught, U naught, and this will become D upon Fe. When nothing is mentioned, object distance is not given, we can replace the VO by L and U by F naught. Correct. If we talk about the telescope, and we know that only that numerical study of the refracting type of telescope, if we consider the general formula, what is the general formula of magnification? What is the general formula, guys? We can already calculate in the previous slide what is the general formula, that is FO upon UE, and we can say that the magnification in the case of the near point, we can see this magnification is FO upon Fe plus FO upon D. In the case of the far point, this can be written as, guys, FO upon Fe. So we have to clear in conceptual clarity what is the magnification and when we have to write down the different types of formula. Let's move for the next section, that is the resolving power. Sometimes, guys, what is happen, it is asked in the problem, what is the resolving power and what is the limit of resolution. So firstly we have to try to understand what is the meaning of the resolution. It tells the ability of objective lens to resolve two objects distinctively. Suppose, guys, if we consider, suppose this is our eye. Suppose if we consider that, suppose this is our eye, correct, and two object is placed. Suppose two object A and B are placed such a distance, say this is the X, and we can say in this, when object is placed at X, we can see the clear image. If we increase the distance of AB from our eye, so there must a condition come. After that, we can't see clear image. We can see this is depend upon the angle subtended by the object in our eye. This is depend upon the angle subtended. As object is moving from our eye, the angle subtended by object continuously decreasing. So we can say there is a limiting angle, critical angle, when we can see the two objects distinctively. After that angle, we can't see clear image. So we can say there will be a minimum angle theta for which two objects just resolved in image, that is known as the limit of resolution. If we consider this is the angle theta, when we can say the clear image distinctively, so this is our theta, and resolving power is nothing but thus it is defined at the reciprocal of the limit of the resolution. Correct, guys? So here we can define the resolution. Here, if we talk about the what is the resolution for the human eye, so for human eye, how is it defined? That theta is defined as 1 point. We have to also take care about this formula, 1.22 lambda upon D. So what is the D here, guys? D is nothing but this is the aperture size of human eye. D is the aperture size, and what is the lambda? Lambda is the wavelength. So here we can say resolving power, that is the reciprocal of this. This can be written as 1.22 lambda. So here we can say that resolving power is directly proportional to aperture size of human eye, and resolving power is also inversely proportional to 1 upon lambda. Sometimes the question is directly asked from the this section. So we have to be very careful about this. Correct. What is the limit of resolution for the telescope? Suppose if two stars, suppose this is the star 1, this is the star 2, and this is our objective lens. This is our objective lens sometime this. And if we want to see the clear image, we can say this is the angle theta. When we see the clear image, so how theta is defined here, where we can see that here this distance d is the aperture of objective lens, and this is defined at the same manner that 1.22 lambda upon capital D. So we can say that D is nothing but this D is the aperture. This D is the aperture of objective when we see clear, distinct object, two star distinctively. So we can say D is the aperture of objective lens. We can say D is the aperture of objective lens, correct. And what is the, if you want to see what is the distance between two stars, how we can calculate it? We can calculate, if we know this distance x, we can apply that E equal to x into theta, correct. That arc equal to radius into angle. For the large distance, we can consider this. We can also find that distance between two objects, correct. In this order, we can also say that if A and B, two object is placed here, and in order to calculate this distance small d, we can say that if this angle is nothing but, if the angle subtend, this is theta, D can be written as, guys, that if this distance is x into theta. I hope this is clear for you. And we have to remember this formula, what is the proportionality and how this is varied. The last is that is the limit of resolution for the microscope. Right? When we consider the microscope, we consider that suppose this is a lens, say this is the objective lens, and if any object is placed at this focus, if we placed at object at this focus, say focus of this is F, correct. Then what is the happen? The angle subtended by the object, we can say that if this angle is beta and this angle is also beta, so here beta is known as the semi-angle. We can, what is the beta? That is the semi-angle made by aperture of objective. Aperture of objective. So we have to very much clear what is the beta semi-angle made by aperture of objective when object is placed at focus. When object is placed at focus, correct. So this object is placed at focus. So what will happen? We can say that if this object is placed at focus, and we can say that this ray is passed in such a way, and this is nothing but, we can say if this is the distance, what we have to measure D. How we can measure this distance D? This D is written by a formula. We have to just remember the formula: 1.22 lambda divide over 2 mu sine beta. What is the beta? We already know, semi-angle that made by aperture. What is the mu? Mu is the refractive index between medium present between object and lens. So we can say this is the refractive index of medium between medium that present between object and lens, correct. And the term mu sine beta combinedly in the combined form known as numerical aperture. Sometime it is asked that what is the numerical aperture? In the case of the microscope, we can say mu sine beta. So mu sine beta is in combined form known as the numerical aperture. So this is all about optical instrument. In today's class, we firstly cover that human eye, defect related to human eye, then simple microscope, compound microscope. Later on, we will discuss about that in the telescope, and most that our focus in the refracting type of telescope, and consider all the situations and cases, and last that the concept of the limit of resolution. So I hope guys this is this is clear for you and this class is beneficial for you. Thank you so much.